Hello, in this video we will talk about VoIP security test tool that we develop, the StarTrinity SIP tester and voice security test and validation suite. Recently our customers asked us to work in the field of VoIP security, so we adjusted our SIP tester products, existing products, with new security features and especially SIP fuzzing or malforming SIP packets. So our software sends VoIP calls, sends and receives SIP calls, and it injects malformed SIP packets, randomly malformed SIP packets. So we analyze well-known exploits. For example, in Google, if you look for denial of service Kamailio CVE, let's look for well-known exploits. What do we see in Google? Okay, this one. We see an explanation how to crash Kamailio's server by sending a SIP packet. We are interested in this. Two-header processing, a specially crafted SIP message with double two header and an empty 2 tag causes a segmentation fault and crashes Kamailio. So what we did in our software, we created a random SIP fuzzer which injects exploits like this. We analyzed about 30 exploits so far, and we will continue. And the SIP tester randomly injects the exploits into valid SIP packets. And here's the architecture of what we do. We have a web server which manages a cluster of SIP testers, and the SIP tester executes callxml scripts, and callxml script can contain such elements, callxml element, add SIP malformer, and the element I will show you here. So here's the SIP tester. We run it on the first server. We run the SIP tester. SIP tester has an option of VoIP security features. So here is callxml script. Please read documentation for callxml and SIP malformer elements. It is available on our website. So the script, if it's a common element in all programming languages, here it means that we just enable the block with SIP malformers. And we have multiple SIP malformers in script with parameters, probability. This is random malforming. So it's not like a list of test packets. It is a list of malformers, and every malformer generates random modifications in the packets. So, and after setting malformers, we make a call with caller ID. It's a valid SIP call without malformers, but if we add malformers, some packets will be modified by our software. Okay, so we make a call to another server with fake SDP equals true. So we don't simulate RTP here because we test Kamailio right now. We don't malform RTP. We only care about SIP. Okay, we make a call and just drop a call in 2 seconds after answering. Okay, this is outgoing callxml script. It means it is call generator. France6.startrinity.com. We have Kamailio running on this server. So France6. So now it's not running because it crashed recently. So we run it again. Okay. Let's see. It's running. Kamailio. So we found an exploit using Google for the Kamailio and integrated it into SIP tester. And now we start. Oh, one more thing. So how we set up the tests, Kamailio. We make calls from France, from Netherlands server to France 6 server, and Kamailio just proxies SIP calls to France 2 server. And on France 2 server we have another SIP tester running, incoming with incoming calls handling. Also, it has SIP malformers set up, and it accepts the call, waits for 2 seconds, and ends the call. That's an easy script. Okay, this is incoming server. Now I start call generation. On Netherlands server, start, and we see that counter of attempted calls gets incremented, and let's take a look at the server. We see that Kamailio is not running anymore. It's not here. Let's restart again. Restart and see. Not running. Maybe it crashed immediately. Okay. We stop call generator and we start Kamailio again. Okay, it's running now. Now I start call generator. Here. Netherlands. Okay, so you see it started. Kamailio is here, and what? Still running. Oh, and disappeared. So it crashed. And what do we see in zip trace? In zip trace, CDR. In our zip tester, we can check zip trace for previously generated calls. Refresh. No response. Let's see that. No response from Kamailio. So it got really crashed. So I'm not an expert in Kamailio. I don't know how to debug it. I'm not a Linux expert. We work on Windows. So I don't know how to see why it crashed. But if you are interested, please contact me. We can run some tests, I think. Okay, and again, one more time. Netherlands. If we create a single call, few calls, what do we see? They got answered. Okay. And if we run call generator for a short time, Kamailio gets crashed, and we check CDR again. Yeah, no response. Okay, good. So now about malformers, types of malformers. What do we have? In zip tester, documentation, add zip malformer. There are a few types of malformers, and the most powerful is recommended hard-coded. In C# we have integrated publicly known exploits, so it randomly inserts them into zip packets. And these exploits are custom set by callxml scripts. Okay, repeat. What does it mean? Repeat. It means repeating of ACK packets in this example. So if we enable this malformer with probability 10%, it will repeat ACK packets for 10,000 times. You know, in zip it is legal to retransmit ACK as many times as you want. And by repeating ACK too many times, you can cause denial of service. So, and this is how we crashed free switch recently. Kamailio didn't crash because of too many ACK packets. Next, all malformers are set up to the SIP call in sequence, and so first it repeats packets with 10% probability, and after that, for every packet of 10,000, it applies next malformers one by one with probability. So it means that 2,000, approximately 2,000 calls will be modified by next SIP malformer with type recommended hard-coded. And this is the most powerful malformer, but it is hard-coded in our C# code. So next, generic buffer overflow. It inserts randomly. I'll show you logs to explain it better. SIP tester writes logs. We use file manager to look at the logs. Log files are too big for standard notepad. So SIP tester logs, and I'm checking log file. Here's log file. So the log file contains SIP traces and many other details, our internal details. And let's find an example of malformed SIP packet. No. This is repeat malformer. You see, it repeats by packet too many times. Next, what do we see? I found it. So here is malformed SIP packet. Invite. So the malformer with type generic buffer overflow randomly inserts large strings into SIP packets. Large strings like this, randomly, at any position, and it can cause crash, but not necessarily. And our purpose is to make many calls and achieve crash. And when we see the crash, we take a look at logs and see which packet caused the crash. And we reproduce it after that to fix it, to understand what happened in zip stack. Okay, what else? Malformers. Digits, it randomly insert digits with probability. Buffer overflow. Digits. Modify single bytes. It randomly modifies bytes one by one with some characters. For example, for quote character, ASCII code is 34, and this malformer randomly inserts quotes into zip packets. Single quote, space characters, it inserts spaces into zip packets, and so on. Replace line. This is needed in a case when you need to reproduce some specific malformed packet. For example, it is disabled here because just for example, so this malformer, if we set enable to true, replaces line, this is the first line in response, with it replaces line contact with another contact, and you see it is not valid IP address, and this is filter, so it replaces contact header by a malformed contact header with bad IP address for response zip packets. Okay, what else to say here? Maybe that's all I wanted to say. So we will continue the research. Too many software products to test. We will test free switch more, publish some exploits. If we find exploit, we will publish Kamailio, whatever, and some commercial products we will also test. And you can also test using our software. Okay. Goodbye.